Okay, so hopefully all of you had a chance to fill out attendance by now. So today, as it says on the slide, we're going to be recapping what we did for the LM CTF project last semester. And then I'm going to be going a little bit over about how we're going to do things a little bit differently this semester and some of my plans for that. Okay, so hopefully by the end of today's meeting, you're going to want to apply for this. We also have the Rec CTF challenges because our CTF that we're hosting is coming up. So if you're interested in writing challenges, you can ping me on Discord. And this QR code is for the LLM CTF project, which is again what I'm going to be talking about today. If you have any questions beyond what we talk about, you can ask them at the end or ping me on Discord. But yeah, that's the QR code. I'll put it up at the end of the meeting again. Also, one of our sponsors, Magnet Forensics, is hiring. If you're looking for an internship over the summer, you guys should definitely scan that QR code and fill it out. As always, we have our meetings at 6:30 to 7:30 on Tuesdays and Thursdays, Tuesdays being the CTF meetings and Thursdays being the general meetings. We also have a Google Calendar that you can subscribe to, and it will put all the not only the meetings, but also like CTFs and other events that we hold on your calendar and send you reminders and stuff. And it'll have like the locations and times and everything. So I think that's pretty convenient. Let's see. So we have a CTF coming up this weekend, Dice CTF, which is one of the most prestigious CTFs. So I think it'll be definitely fun if you guys come and compete. We're going to be in the student center from 11:30 a.m. to 7 p.m. And we will have pizza, so it'll be fun. Also, if you guys don't know DEF CON 404, or I think DC stands for DEF CON, I'm not sure, but it's like DEF CON working group. So basically, DEF CON is like a once a year hacker conference in Las Vegas, but they have working groups throughout the country, and we meet up every month. I've gone with some people from GreyHat before in January, and it was a lot of fun. There's a bus that goes from the bus stop right outside Nav all the way right in front of I think it's called Manuel's Tavern, where they have the event, and there's a bus all the way back. But it's not too bad to walk as well. So it's a lot of fun. We're going to be going as a group this March, I think, unless something comes up. So yeah, I would definitely recommend that. We're still deciding on whether we want to do more CTFs after this, so we'll post announcements once we decide on that. Another event we have coming up is Professor Perillo's job information event. So he is very experienced in the industry. He joined the New York Stock Exchange back when it was a very small startup, and it grew into what's now worth over $100 billion. So he has a lot of experience in the enterprise space, and he's going to be talking about how to evaluate job offers and what like stock options and salary and what to think about when you get an offer. So it's going to be very informative. Last weekend we had a CTF, Sternland. We had placed about in the top like 1/4 of teams that had more than one solve or one or more solves, which is not super great, but hopefully we'll do a lot better this weekend at Dice CTF. You guys should all definitely come and help out. And if you want to practice, I believe the infrastructure is still up, so you guys can try out the challenges. If you were at the CTF and you want to be featured on a website as a competition team member, all you have to do is submit a write-up for a challenge that you solved, and you'll get featured on our website, both your write-up and under our team member section. So yeah. Okay, so I'm going to go a little over how we structured this project last semester. So the way we structured it was more of a competitive format where we had 8 teams, and each team had 4 people, and we had everyone apply to the program, and then we had them make their own teams. So we had 51 people apply, and the way we scored it was that every week we would have evaluation set of challenges that we'd run. Some of these challenges would be provided by the challenge organizers, or I mean like the project organizers, but most of them would come from other teams. So every team would be required to submit one challenge, and that would get them defensive points, and then they would try to solve the the organizer challenges, and the other team's challenges to get offensive points. And many of these challenges came from the NYU CTF database, which was like seesaw challenges. And yeah. Okay. So this is a little bit about the people that applied. We had mostly first years in the program, and a lot of them, well, most of them didn't have like any CTF experience. Let's see. Yeah. And we had a good mix of people who were interested in LLM agent development, software engineering, and CTFs. So pretty diverse group of interests. So the way we structured it last semester is that Socket, who is running the project, gave everyone a boilerplate agent. And the way it worked is there was a Docker container, and inside that Docker container, there was a little bit of Python code that would basically make a request to the API through the Light LLM is basically an intermediary layer between whether it's OpenAI, Claude, Gemini, whatever API you want to use in order to generate your responses, right? So that's a standardized API, and we just had a loop that it would call that API, get the response, and then if it would parse out whether it's like a shell command or something like that, and then we would call it again. And it would just do that in a loop until it parsed out something that it looked like a flag. So it'd use regex to parse out a flag, try submitting that. And then the only thing visibility you got into it was the total spend and the request IDs and stuff. And so it was a pretty simple, basic boilerplate architecture. And eventually, towards the end of the semester, we also got an integration with CTFD. So we didn't have just local challenges. We could run it against remote challenges. Let's see. So some of the things that the teams tried was, I know that team 1 tried implementing MCP to give the agent access to different tools in a more structured way. Because again, the boilerplate agent, all it did was it searched for a specific regex pattern of what a shell command looked like. I think it was like any line that started with a $sign or something like that. And that was extremely inconsistent. For example, even if a lot of times what happened was the agent would output a bullet pointed list and then it would break. So team 1 implemented MCP from scratch by hand with no libraries, which unsurprisingly did not work out so well. Yeah. They had a few timeout issues, unreliable tool calling, and bloated context were a few of the issues that they had. But still pretty impressive that they got it working. Let's see. So I was on team 7, and also team 5, I know, did a little bit of this. I initially tried implementing MCP myself through the recommended MCP library that handles most of the logic for you, and you just write a little bit of code and get it working. But still, it was not as optimized as it could be. So what we did is we switched to using the Codex CLI. I know Team 5 also tried the Claude Code CLI, and that provides a set of well-tested MCP tools. So for example, there's file operations such as reading, writing, there's shell execution, web search, planning to-dos, even subagents, so that's very experimental support. And all of these operations are already very well optimized. For example, file operations, reading and writing to a file. If you were to implement that by yourself, you'd have a lot of considerations to think about. If it's a long file, you don't want to rewrite the whole thing. You want to be able to rewrite just sections of it, do patches, stuff like that. And you'd have to make sure that the agent understands the exact syntax you're using. Whereas if you use the provider CLIs like Codex, right? To use an example, OpenAI expects you to use the GPT models with Codex. So it'll already have trained the model based on the exact tool calling format, whether it's like a patch format. I think it's like a Git patch format, right? And a lot of these are already very well optimized. For example, the web search, it would be very difficult for you to implement that by yourself. I think there are some things that you can integrate with, but it's so much easier if you just use what's already built for you. It's already well tested. The other thing is that when you use these CLIs, often you can do it through a subscription, which is extremely subsidized. I'll talk about that a little bit later. But this allowed us to use a lot more credits than if we just used the API billing. Yeah. Okay. So another thing that Team One tried out is tiered agents. So what they had is a main orchestrator agent, and they had sub agents that would try to solve specific problems. Um, However, they had some issues with guiding the sub agents towards the things that they actually wanted them to do. Sub agents often wanted to solve the whole task by themselves, so they went back to using just one agent for the whole thing. Something that I tried on Team 7 was automated training. So once we got once we had Codex itself handling most of the logic and the MCP servers and all the operation stuff, what we really wanted to focus on was teaching it the skills that it needed, the strategies and techniques for solving CTF challenges. So what we did is we looked for wikis on how to solve different types of challenges and documentation on all the tools that we made available in the Docker environment. And then what we did is we gave all of those to the agent. And what we also did is we wanted to not just leave it at that, but we wanted to update it with new techniques and stuff. So what we did is we created a trainer agent that operated on the host computer, right, outside the Docker container. And it would run an evaluation of the CTF agent against a challenge. It would just pick a particular challenge. And then it would look at the logs from that challenge and think, where did it go wrong? How could it, if it didn't solve the challenge, what could it do differently in order to solve the challenge? If it did solve the challenge, how could it do this more efficiently and in less time and less tokens? And then what it did is it would update a set of markdown files that we had with different techniques and strategies. And we kept running that in a loop. And the trainer agent would have access to the internet to search up different stuff. It would have access to the write-ups for the challenges that were being solved so it can know how it's intended to be solved. But what we found was more effective, at least the way we were doing it, to manually curate resources. Partially because if the agent inside the container, even with like web search enabled, wasn't able to find the solutions to some of the harder problems, the trainer agent on the outside wouldn't be able to know where to look either. So maybe with some more effective prompting and such, we would be able to do it a little bit better. But often what we found is that the trainer agent, was only, was close to as smart as the CTF agent on the inside too, because we were using the same model. So it wasn't able to provide that much additional insight. What we found was a little interesting was that we found a few instances of agents cheating on the challenges. So as you know, the boilerplate that we were given was pretty minimal, and the flag checking happened inside of the container right next to the CTF agent. So what it could just do is run, env, the command to print out all the environment variables, right? And it would see the flag because the flag checker was just another program inside that same container that checked against an environment variable. So yeah, but also the challenges that were solved illegitimately by cheating were also some unsolvable challenges that were set up improperly so that you didn't have all the resources you need in order to solve them. So I think it tried solving it legitimately for most of them, and when it couldn't, it sort of gave up. Other thing we noticed is that Team 7, my team's agent, also used curl to look for write-ups online. Even when we explicitly turned off the web search tool in Codex, it switched to using curl and DuckDuckGo in order to search for write-ups and stuff, and it would search through GitHub stuff. Yeah, we didn't look exactly into the logs too deeply, so we're not too sure if it was just looking for similar challenges or if it was trying to find the exact challenge. It was looking up some details of the challenge, but maybe it was just trying to find something similar. But yeah. This also happened a lot of times when it got like frustrated after running for a while and thought it was making no progress. Okay. I think most of the people who competed last time aren't here, but I'm just going to go over the results from each of the teams. So the way we set it up was that first place would win $100, second place would win $50, and third place would win $25. So the teams that did the best were first place was Team 7, the team that I was on. Second team place was Team 1. This was a team with Vishal, Kevin, Nanda, and Alistair. And then third place was Team 6. Yeah. We'll be giving out like gift cards to the teams with the prize money. Yeah, so if you won and you're not here and you see this recording, please contact us. Okay. So yeah, some details about the testing. Team 4 dropped out, so you're not going to see them on these charts. And round 3 is merged with round 4 because we had some issues with both the agents and the infrastructure. And Team 1 and Team 7 also had some issues with their MCP servers, as we talked about earlier. So that's why they have 0 for some of these. So these were the graphs from a couple of the weeks. So you can see, yeah, you can see my cursor. Yeah. So so you can see Team 4 here is considered as like a baseline. Well, okay, so yeah, they're included. Yeah. So they were in round 1, but after that they dropped out. Yeah. And then you can see there were some issues in round 3 and 4 with some high usage. Yeah. Okay. And this is probably a little bit easier to see. This is the final agent that each team made, and then how they did against all the previous challenges. And then this is how we calculated who won. And then after that, we combined all our agents. Well, really, we just built off of the Team 7's agent because that performed best. So that was the team I was on. So we just forked that. We didn't really have time to make too many changes. I don't know if we changed anything really at all, but we ran it against TK CTF. Yeah. And we were 12th place out of, I think, 32 halfway through the challenge. But then we started to drop off because, the agent solves things faster than humans, but it does have like a skill cap. So, the humans did catch up. Let's see. And then at the beginning of this semester, we backtested against all the challenges in TK-CTF. And we did it a little bit more comprehensively. We gave the agent a little bit more budget and a little bit more time to solve challenges. And we were able to solve 18 out of 32 challenges, which is equivalent to 20th place in total. I think during the competition, we came in at like 23rd or something like that. So a little bit better when we gave it a little bit more time. And this is a graph of the points of a challenge versus the cost to solve a challenge. So TKCTF is similar to how we ran each week, where we would have defensive challenges. And solving a challenge will be worth less points the more other people. Wait, okay. Actually, I'm mixing up two different things, right? Okay. So TKCTF runs similar to most other CTFs, where each challenge has a certain number of points that's worth, and the more other teams that have solved it, the less it's worth. So you can see 250 points is the base value. If like most other teams have solved the challenge, then it is worth 250 points. And then some of the higher value challenges are worth closer to 1,000 based on how many other teams have solved them. And then you can see the cost. So we expected to see a little bit more of a correlation between the difficulty of the challenge and the cost to solve, but we didn't really see that, which was pretty interesting. Also, this says that we spent $39, but I think that is about an order of magnitude off due to like some further testing that I've done, which I'll talk about a little bit later.
Spent $390 on TKCTF.
No, less.
Oh, okay.
Yeah. So we didn't actually use the Light LLM API for this. What we did is we used so I talked a little bit earlier about how we used the Codex CLI, and since we used the CLI, we were able to use subscriptions, right? And I happen to already have a GPT Plus subscription, so we already used that, and we tried to convert the token count into the actual cost numbers. Yeah. So we didn't actually run this through Light LLM, so we don't have actual cost. This is like a equivalent estimated cost. And I'll talk a little bit more about how we calculate that. So yeah, I didn't have time to make like full slides for all this stuff, but I'm going to talk a little bit more now about the new boilerplate that you'll be given. if you decide to sign up for this semester's LLM CTF project. I think it'll be a lot more fully featured. Let's see. Okay. So here. Okay. Okay. So some things that we switched to doing is, as I said, we're using the CLIs for each of the providers. Instead of having you manually write code to call each of the APIs for, OpenAI or Claude Code, or not Claude Code, just Anthropic, and getting each request and then parsing it out. What we do is each of the CLIs, they support. You can do something like codex exec, and then you can give it a command, and it will run autonomously by itself.
You can't see your screen for sharing.
Oh, right. Okay, let me fix that. Okay. Yeah. So all of the major CLIs, whether it's Gemini, Claude Code, or OpenAI Codex, they support running exec, and then you can give it a command, and then it will run autonomously, do that whole thing, and then it'll return the result when it's done, right? So we can do that just for, solve the CTF challenge, right? So that's eliminates a lot of complexity, and since this is maintained by OpenAI or Claude or Gemini, it gets a lot of updates and it's a lot more stable. I'm going to talk a little bit more about the updates it's been getting and stuff. The other thing I added was live logs. So you guys can see while it's running the exact transcript. This is streamed out of the container. So we're not going to have issues where you don't know if it's getting stuck or if you need to give it more input or something. So this will get streamed out as it's running. And the other thing we can do now is you can pause, give it more instructions, and resume. So this is more used for human-in-the-loop CTF solving. But what I can do is, let's see, if I do something like run agent, it's a little bit slow. So I might not just demonstrate each one of these. But basically, let's see. I can give it, I can run a challenge, and I can run, I can press Control C in order to interrupt it. And what that no longer does is it doesn't just stop the container. It sends an interrupt signal into the container, and the container sends an interrupt signal to Codex. And that is basically equivalent to if you press Control C while it's running. So it'll save all of its state, and it will gracefully exit. And then if you want to resume the last challenge, you can just pass in the same challenge with -- resume, and you can give it an extra prompt, and then you can tell it actually try this.
I should look at the screen.
What?
Oh, the speaking label is conveniently covering up finger typing.
Oh. Okay. Yeah. So you can tell it to try something with slightly different instructions. And that'll be pretty useful for CTFs and stuff. Yeah. Okay. And I'm going to go a little bit over the new eval results structure. So now instead of just having the final result, whether or not it solved the challenge, and the agent.log, which is something that we added to our Team 7 agent last semester, we're also saving the entire contents of the Docker. So we have the working directory. So everything it tried out while it was trying to solve is saved. We also have the source artifacts from the challenge, everything that was downloaded, if it was a remote challenge, or if it was a local challenge, everything that was artifacts that were provided. we also have the agent configuration, which I'll talk more about later. And we also have the provider state, which is everything that the CLI needs in order to seamlessly continue again, right? Because when you do stuff from the CLI, there's like codex resume, so you can seamlessly restart a previous coding session that you had. Well, all of this just gets saved into a config file where you have previous sessions. So all of these get saved before, and that's how we can do resuming previous runs. Okay, so I'm going to show you a little bit about the config files. So I think this will make it a lot easier this semester in order to build the agent. Let's close all this. Okay, so instead, so now we have configs for each agent configuration. So you can give it a provider and a model that you want to use, and then whether you want to use a subscription-based authentication, or if you want to use the light LLM authentication, and then a bunch of other parameters like whether you want web search, the timeout, and the reasoning effort, and what sort of MCP service you want to give it. So we have a bunch of different MCP servers that you can choose from, but this just allows you to easily configure which agent you want to use, and you can just pass that in through a CLI option. But what if you want to use more than one agent? So what we have now are we have pipelines where you can have, for example, if you want to have a web pipeline where you have one agent that does recon, right? And then another one that actually tries to do the exploit, another one that does like planning or something, right? So what you can do is you can give it an agent config, which is just a pass to one of these other configs, and then you can provide specific overrides and specific task instructions for that specific stage. And then you can have another stage that depends on the previous stage, sort of forming a directed acyclic graph, right? Where one stage feeds into the next stage. And then in this, you have another agent config and instructions, and you can tell it to copy the a specific folder from the other one. So you can see in the first stage, it says save all your findings to working directory / recon.md. Well, you can see in the next stage, it says copy the working directory into the next stage from the recon stage, right? And also copy the provider state. And if you remember, the provider state, this is what had the full conversation history. So it will have every single tool call and every single thing that the agent tried in its history, which will be copied over. But you can also have different kinds of pipelines where you have multiple stages running in parallel. For example, maybe you want Claude to Opus to run at the same time as GPT Codex, and you have a timeout for each for maybe like 10 minutes. If neither of them solve it, then you want Opus to run again, and you wanted to keep the conversation history of the previous Opus run, but you also want to have the working directory of Codex with everything that it tried, and you want to have the working directory of Opus. And you can merge those all together into the next stage of the pipeline, the agent. So in that way, you can have multi-stage pipelines of specialized agents, and you can copy the results of one agent into the next one in order to inform your next agent. We are in the process of supporting native subagents. There's a PR for it that I'm working on right now. But inside each stage, we're also going to have the ability to have subagents that are being orchestrated by the main agent. Most of the CLIs right now, whether it's Codex, Claude Code, or Gemini, have natively support subagents, but they're all very experimental. So basically, it'll be like, yeah, I don't think there's a config with it already set up. Is there? Yeah, okay. But basically, you would just add a separate MCP server for a subagent and say what kinds of subagents you would like to make available. So if you want to have a less powerful agent, like say like Claude Haiku for like scanning through a really, really large file, and you didn't want to bloat up the context of the main agent, that is something that you could do with subagent. We've also added a bunch of different MCP servers. Like I said previously, there were some issues with cheating last semester where the agent would look in its environment in order to get the flag result. Well, now we have a separate flag checker Docker container, and it's done over the network where it sends a network request with a proposed flag. and the flag checker will check the flag for it and send the result back. So this avoids like cheating concerns because the flag is never sent into the container. We also have a bunch of other MCP servers. So for example, we have Context 7. So that allows you to look up documentation for all sorts of libraries and other sorts of coding tools. And it loads all of that up into the context of the agent that it can request whatever it needs. For example, if it's like doing something really niche in some sort of library, I think Context 7 has a bunch of them. Let's say React. I mean, React is probably very well trained on, but it can find all the documentation without having to do like a web search or write out like code in order to test out stuff. We also have Ghidra and Pollen GDB, and Netcat. Although we might remove those. I'll talk a little bit more next about that. But yeah, all sorts of. Also, we have Playwright for browser interaction for web challenges. Yeah. So I talked a little bit about how we chose to go with provider CLIs like Codex and Cloud Code. And something new that's come out since last semester is background terminals. So last semester, Team 1, what they implemented was a terminal UI MCP server for GDB and Netcat, where basically the agent could start up an interactive shell. So like something like Netcat, right? You have to you can send a response and then it'll give you something back, and you can send another bit of text and it'll send something back. Or GDB, where you send in like a GDB command, it'll print something out. You have to read it and then send another command. Well, the tool calls back then to the shell, they were just a single bash command that you would give it and it would run. Well, now all the CLIs support background terminals, where you can have a terminal. It'll have a terminal running in the background. And it can send it text, read out text, send it more text, read out text, interactly the same way you would interact with the terminal. So we're probably going to remove these since those are natively supported and probably supported better. But those are like some examples of the kinds of updates that we can get by using the provider CLIs. We also support all the CTF platforms. So you can very easily add support for a new CTF platform by just putting the platform name, the URL, and then giving it the auth details and the flag details. So this is how we configure TK-CTF. This is the GreyHat RCTF platform. This is actually at ctf.greyhatgt.org now. We've changed the domain, but as you can see, it's pretty simple to set up. And even if you have a custom CTF platform, it's also quite easy to set up. All you have to do is give it the base URL, and you have to give it the API URLs of getting a list of challenges, getting a specific challenge details, and submitting a challenge. Once you have those three things, you can just put those in, and you can configure it to any sort of CTF platform. So this is from Certinlin, which was last weekend. So it'll be pretty easy to set up. It's just a YAML configuration file. Another thing that we now support is filtering. Let's see. Yeah, so this is some examples of filters that you can use, right? So you can filter by category. And you can also filter by status of previous run. So like I said, you can resume previous challenges. Well, you can also resume previous challenges. Resume by default will get the last challenge, but you can resume the nth to last challenge. For example, if you want to start off with the conversation history of a specific challenge, but you want to do the the third latest run that you did, you can do that. You can also do filter by challenges that you ran after a specific time, challenges that timed out or ran out of tokens, or just failed, couldn't find it. And let's see. Okay, I was looking for a specific example, but it seems like it's not there. But basically, there is we have a custom filtering logic where you can combine filters. So you can say, I want only web challenges, and you can say you want web challenges and you want challenges that are worth more than a certain amount of points. And then you can group those filters with parentheses and say, or challenges that are pwn challenges, and they are less than a specific number of points, and they have not been solved by me or been solved by a certain number of other people. And so you can filter by pretty much any piece of data you can get from the CTF platform. And this will allow you to, maybe you're in a CTF, right? And you have a specific pipeline for a web pipeline, right? Like I showed earlier with recon and exploitation. And you want to run that against only web challenges that are of a certain difficulty for a certain number of points and that you haven't solved yet. So you can run that once, and then you can run a different pipeline for easier web challenges and a different one for rev and pwn challenges, for example. Or you want to run the easier pipeline or the simpler pipeline on easier challenges, and then if they fail, you want to do -- resume, and you want to run the harder pipeline on them, and only the ones that only failed. So yeah, there's all sorts of filtering options. Let's see. Oh, and now we support parallel execution. So you can, if you have a filter that matches many different challenges, it'll run all of them in parallel. But you can also run multiple commands in different terminals, and all the containers have a unique suffix added, and all the logs have unique suffixes, so nothing will conflict. And you can run as many as you want in parallel. We have a -n option for the level of parallelism that you want. And now we also have more optimized Docker builds. This? Huh.
It's not true.
Yeah. Okay. Okay, I'll just be quick. Yeah. Okay, I'll just be quick. So like I went over, all the container state is saved, so this will make debugging a lot easier. I'll talk a little bit about how the request routing works. So we have, I'll talk a little bit about this next slide. We have a CLI auth proxy, which will go to the subscriptions. And we also have a light LLM sidecar, which is just another container that's running here next to your agent container, which then goes to our GreyHat light LLM server, which then goes to the SSLab light LLM server, which then goes to the OpenAI or Claude APIs. So quite a few hops, but it gets there eventually. If we use light LLM, it'll just use the cost information from there to get your final cost. However, if you're doing it through a subscription, yeah, okay. So it'll go through the CLI auth proxy. So just a little bit of details. I've been using the Codex CLI for a lot of coding this project, the agent. I think, how much did I use? So last week, right, I used half of my weekly quota. That was, how many tokens was that? That was maybe, yeah, that was 250 total tokens, 250,000 total tokens. And that was 500 million tokens if you include like cash tokens and stuff, roughly. I don't know. But I do remember I converted it into dollar amounts of API usage, right? So that was, in 1 week, that was $115 worth of API usage for half my quota. I ended up using the whole quota after that. I think it came out to $250 for 1 week, which would be the equivalent of $1,000 for a month of usage, right? So with a $20 a month subscription, I'm able to get $1,000 a month worth of API usage. Codex is much more generous than Cloud Code, but even that is extremely subsidized. So we want to use the subscriptions instead of just paying API rates. So what I did is Codex is open source, right? So I downloaded the repo and I sort of reverse engineered how it works. And then I set up a proxy. So basically what you can do is in Codex, you can tell it to use a custom base URL and API key like you were connecting to a light LLM server. And I set up my own server where you connect to that. But this server that I set up pretends to be a regular person on a subscription and just sends it to the subscription endpoint instead. I had to do a little bit of getting around some restrictions. So this might end up getting blocked. But for now, this is what we're going to do next semester. So it'll be very heavily subsidized. We're getting a Claude Max subscription as well. So we'll have access to Codex models and Claude Max. Yeah. ChatGPT right now, if you just set up a free account, gives you Codex usage. So what I did is I made got a dozen emails and made a bunch of accounts. And now this CLI proxy automatically switches between the accounts. It checks the usage on each account and automatically routes it to the account with the most remaining usage on the free tier. Also, they have a little bit of bypass safeguards against this. I think they make sure that you're on the same IP address as the machine that you're running Codex on and the machine that's actually sending the request to their server. So there's been a little bit of issues, but I think if you're on the GT Wi-Fi and if my proxy is also on the GT Wi-Fi, it should end up being the same IP address, so they shouldn't be able to detect that. But we're working on figuring that out. Yeah. Anyway, if you're using the auth proxy, what we do is we count tokens, and then from that, let's see. Yeah. So you can see here the token count pricing that you just put into the config, and from there we determine the cost from that. From what I found, I've tested with light LLM versus the CLI for Codex, and for Codex at least, it's been accurate down to the thousandth of a cent. So it's pretty accurate. And okay, my computer is actually gonna die, but since I've done all the hard work of building out the infrastructure, every single thing that you might want to do, whether it's multi-stage pipelines, sub agents, all the MCP servers. I didn't show it, but you can easily add a new MCP server with just one config file. If you want to add different provider CLI, everything's extracted out. So you just have to write one Python file. So what I really want to focus on this semester is more of a research angle where all the configuration is in YAML. I want you guys every week to try out a different type of configuration, whether it's do subagents actually help out? Because team one, it didn't really help them out. Subagents got confused. But maybe with better prompting and better direction and better tools that you make available, maybe you can actually make it work. I want to try different types of pipelines, as I said, different type of tools that you make available. If you guys are domain experts, maybe you're really good at malware reverse engineering, really good at Rev, Pwn, or maybe you're really good at a specific type of crypto or a really niche forensics tool. Okay, my computer died. What I want to do is I want to make it so that each week we focus on a specific area of agent architecture, and then each of you guys tries out multiple different approaches, and we'll have so many credits available, through the shenanigans that I've been running, for you guys to run lots of comprehensive testing on different ways of architecting the agent. If you guys want to edit the code and optimize the infrastructure and stuff, that's great. I'd love to accept contributions for you guys. But even if you guys are a little bit less technical, but have know a little bit about how agents work and have some creativity for different ways to build the architecture, I want to make it available for you guys to contribute to that. Was there anything else on that slide? I don't remember. I was going to go back to the QR code to fill out the applications, but my computer's dead now. Time is it? Oh, well, meeting's almost over anyway. So I'm going to post the sign up link or the application link in announcements, and you guys can fill that out if you're interested in joining.
Ash, when's the deadline to fill out the application?
The deadline to fill out the application is next Thursday night at midnight. That's one full week, plenty of time. Don't miss the deadline.
Let's just submit for the deadline.
Yeah.
CT students might not know this. Anyway.
Yeah. If you guys have any questions, I'll be around here. You can also ping me on Discord. It was on the slides, my Discord username.